Hi, my name is Pallavi Kaushik. This is a pre-recorded presentation for the 2020 International Conference on Cognitive Modeling. In this poster, I am presenting our work on decoding focus and distraction in the intriguing setting of monastic debate that's practiced by the Tibetan monks in India. Before we get into that, let's just see the motivation that lies behind this work. So why focus? Why attention? Attention plays a very crucial role in our day-to-day lives, and lack thereof can lead to traffic accidents, medical mishaps, etc. This leads to the dire need of developing systems that can be used in real-life settings to indicate if a person is attentive or not, so that these accidents, or well, at least some of them, can be avoided. A lot of work has been done to distinguish the states of focus from distraction using EEG and machine learning. But majority of these studies work on data that are collected in labs where the participants are levied with a lot of constraints on their movement, speech, etc. Hence the results cannot be fully generalized to the real-life scenarios. Another gap is that since supervised machine learning requires labels, many studies used probes to ask participants in between the tasks if they have been focusing or not. This disrupts the attention of the participants, and since we are set to learn about attention during the task, this might affect the results. Very few studies have worked on analyzing attention in real-life situations, but they fall short in terms of the number of participants or the quality of the EEG equipment used. With this study, we want to attend to these problems, and we want to see if EEG can help in predicting instances of attention in real-life setting. The real-life setting we decided to occupy ourselves with is Tibetan monastic debate. This is a situation that my supervisors have been studying for a while now. It is attractive because it goes beyond the usual Western settings, and its very rich setting involves many moments of excitement, boredom, and quite a few emotions. Very briefly, this form of debate differs from the Western debate in the physical setting, where the challenger stands and the defender sits, as shown in the figure on the left. Another major difference lies in the fact that in the Western debate you try to convince your opponent of your viewpoint, but here you try to find the inconsistencies in reasoning. The flow of the debate is shown in the figure on the right. To find more about the debating style itself, you can check out the poster by Stefan Regel. This slide provides the framework of the study. EEG data were collected from both the participants simultaneously using a 32-channel EEG device. Data were collected from 46 debates, and each debate lasted for about 10 to 15 minutes. For the pre-processing, low and high-pass filters of 45 and 0.5 Hz were used to remove high-frequency muscle activity. Independent component analysis was also used to remove muscle artifacts. It is known from the past studies that the alpha and theta waves are representative of attention, so discrete wavelet transform was used to extract these brain waves. Once this was done, random forest classifier was used for classifying focus and distraction. An important thing to state here is that videos were also recorded during each debate. 3 senior monks labeled the instances of focus and distraction while watching the videos, and an instance was labeled as focus or distracted if majority of the monks labeled it so. This labeling method was used instead of the probes for labeling, so that the flow of the participants during the task is not disturbed. In order to extract the EEG segments corresponding to our events of interest, we extracted 2-second segments from the EEG signals. There is an imbalance in the data where 42 segments correspond to focus and 142 to distraction. To balance the data, we randomly selected 42 segments of distracted data. T-test showed that predominantly central and parietal electrodes showed significant differences in oscillatory power between focus and distracted states. The random forest classifier gave the maximum accuracy of 99% in theta and delta waves. In conclusion, I would like to say that EEG data collected from a naturalistic setting can lead to classification of moments of focus and distraction. In the future, we would like to work on an even larger dataset and classify more subtle states like emotion in a real-life setting. Thank you so much.